Um, Again, welcome everybody. Glad to have you here. My name is Michael Irwin. I'm part of the developer relations team here at Docker. And again, excited to have you here with us today. If you're new and just joining us and haven't heard about the AI Machine Learning Hackathon series, we'll drop a message in the chat and link to let you join and catch up with all the resources, the other sessions that we've had so far as well. And again, we're excited to have you here with us today. I'm excited to introduce Andreas, who's joined us from Neo4j. Um, I'm excited to learn about lots of the things that Neo4j is doing. I've actually been using graph databases quite a lot, and Neo4j is a great tool for doing that. So it's fun to see Neo4j being used in this new AI machine learning space as well too. So with that, I'll pass the baton off to him and let him introduce himself and go from there. So thanks again for being here with us.
All right, Michael, thanks for having me here today. It's great to be here. As you just mentioned, of course, I'm Andreas from Neo4j, also known as ABK from Neo4j. But for today, you can just call me, Andreas if you're in the chats. I think that's how it'll show up. And Neo4j, of course, is a graph database. We're part of the recently announced GenAI Stack that's came out from Docker and some other partners, and I'll talk through kind of the overall that bit of the stack, how it's all put together, and then zoom into actually the Neo4j piece and discuss how does Neo4j and a graph database and generally how to use databases along with GenAI. So that's the plan for today. I'll go ahead and pop open my screen share, which just traditionally takes a minute to figure out to do correctly. And this just worked. Let me do the entire screen. Can I share that? Let's do an entire screen share to get some lovely kind of zooming effects going on. Okay, so with any luck, and let's do this slide sharing over again, we should be here at the top with the intro to Neo4j on the GenAI Stack. Okay. And of course, the context for all this, why we're doing this as part of the hackathon, for each of these sessions, you're learning a lot about how to do stuff on Docker, lots of fun things you can do. Particularly, of course, it's part of the hackathon. So these are all different ways you can use different technology to actually win the hackathon. That's the ultimate goal here, right? So our plan here for today is to review the GenAI Stack that was announced at DockerCon. We'll go over some of the fundamentals of what Neo4j is as a database, how you think about Neo4j, how you work with Neo4j, and then we'll zoom into the parts of this GenAI stack that Neo4j is being used and figure out how to actually modify some of that stuff so you understand what the example code looks like and then how to modify that code for what kind of stuff you actually want to do with GenAI. And this is the essence of the talk, really. The outcome here is that GenAI is amazing. That's the entire talk. This has been my TED Talk, and thank you. I'll now take questions. Michael, are there any questions yet in the chat?
No, nothing yet, but that was a great talk.
That's the fastest talk I've ever given. Okay, well, maybe we'll continue then. So, okay, we actually will dive into some of the details. The reality, of course, is that GenAI has been amazing for everybody, and we're all trying to figure out what to do with it, how to work with it. The GenAI stack from Docker is really an attempt to put together the essential components of what you need to actually just do your own GenAI stuff in a very nice package, easily get it all spun up, and then just kind of modify it for a purpose as you'd like to. So we'll be talking a little bit about, of course, Docker and llamas and graphs. Oh my, this will be fun. And for GenAI generally, why the whole stack actually is relevant is it's not just enough to just have ChatGPT. ChatGPT, as we know, is absolutely just world changing. It has been fun to actually see all the different things people are doing with it and the different applications and different technology areas and just all over life, right? But ChatGPT is by itself not enough. It doesn't actually understand much about very particular domains. It's kind of outdated information sometimes. You can try to do some amount of fine tuning. There's some limitations for what you can actually do there. And when you get answers from ChatGPT or other LLMs, you don't necessarily know why it's come up with the answer that it's given you. It can't really explain itself necessarily, or you can't explain to other people how it's gotten that answer, which brings up the problem of you don't know if what it's told you is completely true or sort of a lie. That's where hallucinations come in, of course. And depending on what the training data was, there's, of course, concerns about potential ethical or data bias inside of the data that's been trained, the model's been trained on. So for all these reasons, it's good to like think about all the LLMs as a really fantastic tool, a great natural language tool, but really not a complete tool. It needs to be have other tools around it to be a complete story and be really successful. And one of the patterns that has emerged, pretty quickly, really, that everyone is really excited about, and I'm sure everybody out there has already heard about this, is improving GenAI with retrieval augmented generation, what's known as RAG, of course. And RAG, just for a quick review, if you haven't actually heard about this before, so what does all that mean? You've got an LLM, you can just type in some questions to it, it gives you some responses, and that's really great. The RAG idea is that instead of just taking a question from a user and directly giving it to the LLM, it says, well, let's take a little side trip here, work with the LLM to figure out what the user has just typed to us, and maybe go ask a database that might know something about that, or has some factual information we can add to the conversation. Package that all up in a way that the LLM can then, present back to the user in a nice, friendly way, again, through natural language. And that kind of loop ends up being much more powerful. It's then grounded in truth. It's grounded in reality sometimes, but still has all the friendliness of actually working with an LLM. So that's the idea of RAG, and that's what we're going to be getting into today. The key part of this, of course, that we're getting into is the database box down there in the lower left. So the GenAI Stack is the way to do RAG. And the components of the stack are, of course, Docker for orchestrating a few containers. So you've got an LLM, you've got your application container, a database container, things like that, all kind of put together inside of the stack. You've got Ollama around for actually managing local LLMs. Neo4j is the database, for the stack for grounding your truth. And LangChain for kind of stitching everything together on the application side so that all the application logic and the data flows kind of goes through LangChain, stitching everything so that you've got a nice, easy kind of API to work with. If you drill down into the GenAI stack, if you've cloned the GitHub repository, and I should have really added a link to the GitHub repository, I'll add that in the notes on the video channel, I guess. Or if somebody could somebody who knows it, if you add it to the chat, that'd be great. So if you download the stack, if you go ahead and clone it and take a look at what you've got, there are a couple different containers that are present in there. The ones that we're going to focus on are the database container, which is running Neo4j. There's a loader container for basically setting things up. And then the bot container is one of the applications that's available. That's when we're going to drill down into the details today to figure out what's actually going on. This is the overall flow, though, that actually happens. This is kind of the same flow we just looked at, just now put into terms of like what the containers are. Where you have the bot, that's where all the LangChain stuff happens in the upper left right there. The bot, of course, talks to the LLM for actually doing all the natural language stuff. It works with the database by actually, just calling over to the database with normal database queries and pulling out data, combining that through LangChain over to the LLM and getting back the response. And for that bot container, digging into that inside of what you'll see inside of the repository, there are two main files that we'll take a look at parts of. There's a bot.py, so there's some Python code that's there. The bot.py takes care of the kind of the application layer again. So that's where you're going to get the user input. It'll get fed into the RAG process, which is really handled over in chains.py. Some magic happens there, results come back, and then you pass that back up to the user. In the example applications that's there in bot.py, all the user interface is just done with Streamlit. So it's really simple to actually, you don't have to get too distracted by the UI at all. You kind of focus on just like what the overall RAG flow is like. So this is the kind of the one-page cheat sheet for all of that. Okay, the GenAI stack, what is it? It's Docker, Ollama, Neo4j, and LangChain all combined together in a nice package of example code, nice Docker compose for actually spinning things up, and you can use that as a great kind of baseline for building your own applications. And why would you want to do that? Because, well, it's hard to kind of put all these pieces together. I think intellectually it's easy to understand what these things are, but it takes a bit of work. So you can just take this stack instead and use that as your baseline. Out of the box, you already have something that works. You can just modify that, as you'd like, for your customer idea, whatever you want to work on for the hackathon. And you'll have, at the end of the day, this awesome LLM app where the steps are really just setting up the model, setting up the the graph database itself, loading the graph database with some data and the embeddings as well for doing things like the vector search, and then just letting it run. For learning some more details about all this stuff, oh, look at that. I was clever enough to add the GitHub repository. So you can go to that GitHub repository if you're quick enough to type that down or take a quick screenshot of that. This is the key information you need all in one slide. Okay, with that as the baseline, we have some idea about what RAG is. We know that we're going to be focusing on Neo4j, of course. So let's actually dig into Neo4j and get some background on like what it is as a database and how you kind of work with it. And as with any database, thinking about data, modeling data starts with the things you have in the domain you're going to be dealing with. If we're building a chatbot, the things you're dealing with are questions you might want to ask inside of the chatbot. You, of course, have some users who are probably asking those questions. Hopefully, there's some answers that come up. And there's also going to be tags, right, trying to organize the kinds of questions that come up. Each of these things are actually data records, of course. They're not just things. Once you add them to a database, they become data records. And so for the questions, you've got a title, a body, a link to the original source, maybe like here I think we're going to be pulling some data from Stackoverflow. So it'll have a link out to the Stackoverflow questions. Same thing for the user, pretty straightforward. We're just going to give the user a name. They're going to have some reputation from if they've done anything useful on Stackoverflow and gotten some upvotes and thumbs ups and things. Answers will just have some strings for the body of the answer itself, and then whether or not it's been accepted. And for the tags, it's the simplest of all the records we have. It's just going to have a name for the tag that's also present as a string. What's unique about Neo4j and unique about the way that we approach data is that not only do you have these data records, we have explicit ways that these records are related. So it's not just that you have questions, that a user asked that question, and that a user provided some answer, and that answer answers some question. So for each of the things you have inside of your data, you then add some relationships for actually how these things are explicitly connected. And then you've got some lovely, kind of properties that emerge from that. And properties that are interesting when you think about kind of large language models and kind of the knowledge base that they represent, they follow a very similar kind of approach to things in some ways, because these data relationships end up creating patterns, not patterns of text, not patterns of words that you can then kind of guess what the next word is, but patterns of data. So, for example, you can say that there's a user who asked a question. That's a simple pattern from a user to the questions, and there at the bottom there, if you think about that and think about how you would actually write that out, it's very similar to just thinking about tokenizing some text. And the same kind of dynamics occur where like, okay, you realize actually this is just a pattern of data instead of a pattern of text. The users, of course, can also provide answers. So that's yet another pattern. And you can take that same approach of having, a thing that has a relationship to another thing and just keep extending it. And so these patterns can be small. It can just be from one thing to another thing, or you can extend them. Here, it's an answer that answers a question that is tagged with a tag. This can continue as much as you'd like to. You can have multiple patterns. You can do all kinds of fun things once you get in your head the idea that all we're doing here is realizing patterns inside of the graph and then basically doing some pattern matching for finding them inside of the data. That's the fundamental idea of working with a graph database. So if you actually do want to try to get some data out of the database, this pattern matching gets actually expressed inside of our query language. The query language is called Cypher. And if you go back here for just a second and like just looking at the patterns that we have, and you can just read this as if it's just almost natural language. It's pseudo natural language, right? Like there's an answer that answers a question that was tagged as a tag. Here I've taken that same idea. I said, okay, at the top part of this, you have a natural language expression of like, okay, match a pattern of answers to questions, return the Q&A pairs limited to 10. That kind of way of just describing something turns into the bottom code, the Cypher language, where it's much more explicit than like, okay, now this is a programming language or a query language for the graph. And we're going to match a pattern where there's an answer that answers a question, and the return, I've got an A and a Q there inside of the pattern. I'm going to return that Q, return the A, and limit it to 10. So I'm sure everybody that's on this call can just read that stuff, immediately understand what it does, figure out what the result is going to be. And this is one of the beautiful things about graphs is that the way that you would just kind of naturally think about things, the way that usually things are just expressed. And so if you're pretty comfortable with pattern matching in this way, like thinking in terms of patterns and some fundamental kind of query ideas from SQL or Board as well, for things like predicate clauses that can come into play, as you could qualify the answers and the questions if you want to. All this stuff is going to seem super familiar to you and actually quite nice to work with. And of course, this wouldn't really be an LLM, GenAI talk, if there weren't also vectors. And so Neo4j, like all good databases these days, also has a vector index that's available. And so in the data set that we have, you can do vector embeddings for both the questions and the users. I'm sorry, actually, I think that should probably be on the answers, not the users. I don't think we have embeddings on the users. Oh, bad slide work here. But so imagine that I had instead put the user embedding there down on the answers instead. Both of those things have text that we want to actually calculate a vector for, a vector embedding, and then that gets added to the vector index inside of Neo4j. So when you're working with Neo4j, you've got two wonderful ways of actually working with the data that you've pulled from the data source. So you can actually go ahead and vectorize everything, create embeddings, store that in the vector index, and you can find similar documents by just querying that directly. You can then also do graph pattern matching and find related information. So we'll see this actually later on where we look into the details of the bot. But like the vector index for finding similar documents is pretty awesome. You'll find things that are related to the question you're asking. But then if you want to find out more information around that, a better context, you actually want to do a graph search as well. And when you do both of those things together, and combine them in the results, what you end up getting is truly like what we think about as being a knowledge graph. Now you've done a semantic search where it's not just that things happen to look the same, but they're also in the right context and actually has meaning to the user that is asked that question. Combine all that together, you'll get better results for the users because you'll give them a relevant context for them. So here's another cheat sheet. Again, if you're taking any screenshots, this is the one screenshot worth taking. They're all good, of course. Probably the screenshots of me also very much worth taking. But for useful information referencing later, this is probably great. You can think about Neo4j. It's a database, of course. It's a graph database, and it's for storing a knowledge graph. And of course, we've got vector indexes there as well for doing things like similarity search. When you combine the graph searching with the vector indexing together, you get more accurate answers. So that's the semantic search that ends up occurring, that ends up giving you much more accurate results, much more correct, relevant results for the user, I think. And then the steps for doing that are, of course, you've got to initialize it at some point, create the indexes you need, like as you would with any database, including the vector index, load it up with some data, vectorize all your documents, and keep that all inside of one database. So you can do all your vector work and all of your database work all in one source, which is pretty convenient. If you want to learn more about any things about Neo4j, whether it's particular to LLMs or doing things like graph data science or pattern matching, as I described, or how to use it in different programming languages, you should pop out to graphacademy.com, Neo4j.com, where we have some fantastic online resources for learning about Neo4j. Okay. Both of those sections, talking about RAG and then talking about Neo4j, were all just preamble. Basic information you need to know to figure out what are all the parts of the stack. And now we're going to dig down into some of the details of actually looking at how to actually do RAG inside of the GenAI stack within the demo code that you've got available to you if you've cloned that GitHub repository. Let's take a closer look about what's going on there. And all the information I've already told you hopefully has primed you to kind of get an idea about how to work with this stuff. Quick review again. This is the overview of the containers that you've got. There's a container that has the bot, the kind of the front end application and also the application logic and stuff. There's the loader, which is actually creating the graph database and also doing all the vector embedding stuff. And of course, there's a container for the database itself. Within there, the things we're going to start with thinking about is, okay, actually getting the project going. First thing that actually has to occur is you've got to load the data into the database. Otherwise, you can't do any of the RAG stuff because there's no database to talk to, right? So the data source that is used inside of the bot application that's available in the demo, it just pulls from Stackoverflow because Stackoverflow, as we all know, has a fantastic collection of information that's publicly available. And so it's very convenient to pull from that and kind of build for demos and things. Okay, if you look into the loader container, Inside of there, one of the thing that's actually running is the loader Python loader.py file. Inside of the loader.py file, the thing that we're going to focus on is the load operation. There's really two pieces to that. The first is just fetching the Stack Overflow data from the Stack Overflow API. So there's just a big get that kind of pages through getting a bunch of data from Stack Overflow. Somewhere there is, of course, a UI that actually lets you decide what data to get. We're going to ignore that part of it. We're just going to focus on the data aspects. So let's say you've triggered the load Stack Overflow data call. That's really great. It's going to load a bunch of data. Now that we've got all the data from Stack Overflow, we're going to insert that into the database. It's the insert so data call actually inside of the loader.py that does all of the hard work. It calculates all the embeddings for each of the documents that are there, so all the questions and all of the answers, and then it creates the knowledge graph itself. So the embedding calculation is actually done in collaboration with, of course, the LLM that's on hand. If you're just kind of running locally using the Llama 2 model or something, that's just done with the stuff inside of the container. Yes, if you're on macOS, you're probably not running it in the container, you're running it separately, because that's not possible to containerize at the moment. But then you're actually taking that data, taking the embeddings, and inserting that into Neo4j, creating the graph, and also all the embeddings for the questions and the answers, but not the users, because I got that wrong in that diagram. Okay, so stepping into the loader.py and thinking a little bit about the same approach that I said earlier when I introduced the idea of pattern matching in Neo4j and describe things as you just kind of talk about what you want to do, and kind of how you talk about it is what the query looks like. If you look at the query directly on the bottom, you could probably read through that and figure it out. But the top explains it a little bit more here. So inside of loader.py, you'll see a snippet of Cypher code, and it looks like what's up there in the bottom. It uses a merge clause. So earlier I introduced the match clause. The match is for doing pattern matching. It's for reading data from the database. Merge is a little bit like that. It's, you can think about it as an upsert. What merge does is it first tries to match. So if the pattern that you're describing can be matched and is found, then nothing happens other than you have matched that pattern. And here the variable named question will match any of the things you've described here. So if you replace the word merge with match, the first thing that happens is we try to look for a question when ID is the same question as we've pulled from the Stack Overflow API. If it exists, then great, we have nothing to do. We're kind of done, right? But if it hasn't been found, the merge clause is different from match in this way, in that instead of just saying, okay, we're done, if the match doesn't happen, then it becomes a create instead. So, okay, if that thing that you look for doesn't exist, we're actually going to go and create it. And so there's a subclause that we're going to use. So when it is the creation instead of the matching, we have a subclause that lets us do some little bit of extra work. And so on create, we're then going to set a bunch of values. And the logic of all these values isn't really that interesting. We're really just saying, okay, for each of the values that are in the stuff we got from Stack Overflow, we're going to go ahead and set values on that newly created data record. So we're going to set the title, the length, the score. I think all of this is exactly one-to-one. The only clever thing we do here is we create a date time. So, okay, so if you look down where it says creation date equals date time, we actually create a date time data type, not just a number of seconds since the epoch. It's not just an integer. We actually create a date time value there, insert that. And the rest of it is actually just looks like it's one-to-one, right? So this is just creating a value, creating a data record. If it's missing, if it's not missing, if it's already there, then question is just going to be bound to whatever we actually had found. Sounds a little complicated maybe, but actually once you talk through it, I think it's pretty straightforward. The next part then, so we've got a bunch of questions that we've already created, and for each of the tags that a question might have, we're actually going to just run through a little for each loop, which is kind of nice, right? So if you look through this and that first line there where you see the for each, for every tag name that's in the tags from the question. So we've got this q.tags is from the Stack Overflow API. It's got a field called tags. It happens to be an array. We can loop through that array. So that's what's happening here. We're setting up just a for each loop through all of the tags that are in that array, all those values. Each one is going to be assigned to tag name, kind of standard for each kind of pattern. I think every language has something like this, right? And if it's not apparent, after the q.tags, there's a pipe, which basically says, okay, here's how you set up the for each loop, and then apply, after the pipe, it's applying these steps to each of those tag names. So tag name gets passed forward each value of tag name from q.tags get passed into that application side. So we're going to do two things here. Again, we're going to use a merge if the tag wasn't already created. So we're going to go match for the tag. If it already exists, great. If it isn't, we're going to create it. And then we're going to do one extra thing. And this is part of a larger query. So this is just a snippet here. Once we've created that tag, because we know we got that tag from a question, we're then going to create one of those relationships from the question to that tag. I'm going to pause here for a moment and see if that makes sense, right? So going back to the top here and just reading through it, this is exactly what happens. For every tag that a question has, go ahead and merge a new tag node if it exists, create it if it doesn't, and then merge a relationship between the question and the tag. That's all we're doing here. Here's a bunch more code, and a lot of the detail here kind of gets in the way, but now we're doing just more of the same kind of thing. Another for each. We know that for every question that we have in the result set, all the questions are going to have a set of answers. And so we're going to loop through all those answers and do some stuff with those answers. So after the pipe, the thing we're going to do for each of the A's, which is an answer. Oh, actually, I didn't. Let's see, did I do this right? Yeah, okay. So we're going to, again, attach that question and the answer together so that the answer answers that question. We're going to do a merge for that. And for each of the answers that we're just creating along the way, we're going to go ahead and just set those values straight away. We're also then going to create a user for each of the people who have asked a question. And let's see, we're also going to, there's a bit here that's a bit tricky to read. There's also a code lesson here. We're actually going to avoid doing anything with users who have been deleted. So we're just going to skip those effectively. But the result of that is that we're going to merge all the people who have not been deleted. New user records will be created. Every time those people are created, we're going to just set some values on them. And the final step is we're going to merge all the answers to the person who asked that, who provided that answer as well. So through this entire block, we've really just got a couple more data patterns that we understand need to occur for every question. We know that the question has a tag. We also, actually a couple of tags, right? So a question has a bunch of different tags. A question also has a bunch of answers, and each of those answers has users. So for each of those things, we create those things and make sure that they're attached to the thing that we know they're related to. So we've created a bunch of patterns and then things that are connected by those patterns. And then the final step here, I think this is the last thing that we do as part of the load. And again, this is just a snippet. You'll see in the loader.py how this is all kind of assembled together in one big flow. For some of the users, some of those users, of course, have asked questions. So whenever we have a question where there's an actual user there who's asked that question, who's the owner of that question, we're going to merge that owner. So we're going to create that user record and do the same thing. We're going to set values on that record, but a little bit different than before. We had users who are providing answers. This is the final step of saying, okay, now there's an owner, the person who asked the original question, that an owner asked that question. So the key parts here are the two merges as usual here. It's merging new users who are the owner if they exist. And then also if they exist, we'll then do the merger of the owner who asked the particular question. Go through all the questions in this way. And the result of all of that at the end is that this lovely graph appears. And in the left there in the white box, I have essentially the schema again of this graph. Here's what the layout looks like. We've got users who asked questions, users who provided answers, and answers that answer questions that are tagged with tags. And on the right, it's a very small sample of like what the overall graph looks like. And what's fun about this, of course, is that once you've got it in the graph, you can just explore it just as it is, do lots of incredibly useful things with it just as it is. And that's a nice start. So we have all of our data imported, loaded into Neo4j, and created as a knowledge graph, also vectorized along the way. And so now we're ready for the actual RAG part of all this adventure. So going back to, so that was the loader container, going back to the bot container that has the bot.py and also makes use of chains.py, I think, in there as well. That's where the RAG process actually, kind of goes through. Stepping into that, you'll see two files that we care about. It's bot.py and chains.py. Again, this is the kind of flow. I showed this earlier, so this is a quick refresh. Get some user input from the UI, from Streamlit, put that through the RAG process, send the results back to the user, and that's the entire application. Digging into the chains.py part of it, that's where the actual RAG ends up happening inside of this particular container. So the RAG process is all controlled through. So each of these things are from LangChain. So the top box there, the top inner box there, the retrieval QA with sources chain is from LangChain. That's the bit that actually combines everything together, that actually executes the chain of operations. There's two things that really uses that we care about. On the left side here, we do the Q&A chain, so the question and answer chain. That gets done by a call to load QA with sources chain. That's an LLM thing that, depending on the LLM you've got, it knows how to integrate with that. For our purposes today, the interesting bit is on the right side there that we create the knowledge graph using Neo4j vector. And that's the part that actually integrates with Neo4j. All that, the lovely graph that we just created a couple slides ago will then get, queried for both the vector indexing, but also doing a bit of querying on it as well. So the Neo4j vector is part of the LangChain distribution in the framework. It really is the fundamental part of like how you integrate with Neo4j inside of LangChain chains. There's two things you really get out of it. Of course, it's Neo4j vector. So the primary integration point is that you can do vector search with this. And the vector search is an approximate nearest neighbor search, which is the AND search, right? It does either Euclidean similarity or cosine similarity for figuring out for a given vector that you've got, how far away is it from some other vector, the different ways of calculating that. And in addition to doing the vector search, inside of Neo4j vector, you can also do graph searching. And so that's what we'll step into next. So you can do the vector search to find similar documents. And then given those documents, we know that those are going to be records inside of Neo4j. We can do some pattern matching around that to actually get extra information that will return a full result back to the user. So if you look in chains.py and you want to do a graph search for improving the answers, the snippet of code that's here at the bottom in chains.py, you'll see a call to Neo4j vector, and you'll see that it's actually kind of doing the vector part of it. The result of the vector is you basically get two values back that then get passed into the query. So this very top line, the very first line says with node, which is one of the values you get back from the vector search. We're going to rename it. We're going to use as to rename it as the question. We know that the nodes are going to be questions, and the score coming back, we're going to just refer to a similarity. Both of those values are coming from the vector search. So when Neo4j vector assembles everything and does its magic, then calls this cipher query. Right here, the first part of the cipher query that we're doing is just renaming some of those values to the question and then similarity. And we're going to do a very small snippet of a little example of what you can then do. Now that you've got a node inside of the graph and you've got a value about that node that is the value of the score, how similar is this, the kind of the vector similarity, right? The cosine similarity or the Euclidean distance similarity, right? We're then going to do a subquery call inside of cipher here. So that's what the call part is. So it's call curly brackets. And then with that question, now we're just going to do a pattern match. And this pattern match could be as simple or as complicated as you want to. This is the part, if you're really digging into this for the hackathon, where you get to just really stretch your imagination and your creativity and think about like all the different ways you can actually do extra parts to make the answers that you're going to be providing inside of a chatbot or whatever actually application you've got, taking advantage of the graph structures. What you're getting out of the vector search is similarity of here for Stackoverflow, similarity of questions, right? So if somebody in the bot has asked about, tell me about how to use Neo4j with LangChain, let's say, right? If other people in Stackoverflow have asked those kinds of questions, even if they phrase them differently, they'll have a very good similarity score. Those will come back and you'll know that the set of questions you're getting are going to be very similar. So we know that the questions are the same. But then because Stackoverflow also has the actual answers, we're hoping, right? So we're going to then take advantage of the graph search to do a pattern match from here's the questions that were asked, what are the answers to those questions? And then return those answers, but just give me two. Okay, so that's what's happening inside of the curly brackets after the call. And again, this is the part where you want to get creative with what kinds of things you want to extend inside of the knowledge graph for actually providing a richer context and more information about what the answer is, all of which gets packaged up into a result for the user. After the curly brackets, call curly brackets, and then that terminates, we're then just going to return basically a text version of all of that, combine the question title, the question body, all the text from the answers as well, and return that as some text. Also provides a similarity score, and then some metadata, including the sources to the original Stack Overflow questions in the demo application that we have. I'm going to pause here for a second, and this is when I'd love to actually go ahead and ask some questions from the audience. And so actually, if you guys have questions about any of this stuff, do enter that into the chat. I know that some of my colleagues are in the chat right now, so they'll be able to help you. But if not, then I'll come along as well.
Yeah, I'll just jump in a little bit. Yeah, there's been some questions coming in, but I think your colleagues have been doing a great job answering them as well too. So, but maybe I'll just ask the last one that came up here, and again, it's been answered a little bit, but maybe you want to dive in a little bit deeper on it. So Joe asked, how is vector search different from like a Lucene full text index search?
Oh, that's a great question. So I think in some ways, like the mental model of it is maybe the same, where what you're trying to do with Lucene is find, text that looks like something else. And Lucene itself has a pretty powerful kind of language for describing text matching. So, you can ask it for things like, find me text that contains the word Docker, I suppose, right? And it'll find, occurrences of Docker in lots of different documents, and that's really cool. But what Lucene doesn't understand is that it'll try to find words like Docker and maybe variations on Docker. You can do a couple of interesting things with that. And it'll find occurrence of those words, and that's really great. But it has no idea what Docker means as a concept. And the difference with vector search and with vector embeddings is that you would take an idea like Docker or Apple or Box or Person, and instead of thinking about the text that represents those things, the text is just kind of a starting point for a concept that is that thing. So when you do the vector embedding, you take concepts and you take semantics around stuff. You create a vector embedding that basically is a collection of numbers. It's an array of numbers, and you put that into the database, right, as in the vector index. And instead of like looking for text matches, like find me words where does this word occur in the documents, it's like, okay, what is this concept? Where does this concept occur? Or where does similar concepts occur? So a lot of the vector search, to be good or not, depends on like how good your embedding is, what you've actually done for vectorizing your content. Will change, what kinds of values you get out of the vector search. And if I back off for a little bit here and just think about, I guess like one of the easiest ways to think about vectors and doing vector search is if imagine like a color space. If we all know like RGB, right? Like, it's red, green, blue. Those are just three numbers. Those three numbers are actually a vector, right? It represents the red value and the green value and the blue value, but that's just an array of numbers. And if you take those numbers and you put that into a vector index, and you take some other three numbers, put that into the vector index, you'll be able to get an idea of like how far away those two sets of numbers are. That's what the distance calculation actually is. So whether it's the cosine similarity or the Euclidean distance, right? So inside of the vector space, if you put in some other random numbers, visually, you might realize this first number was orange, this first set of numbers was orange, this other set of numbers was purple. But as a result of actually turning them into a vector, the RGB, those are different number values that you can actually calculate what the distance is of those things. And from the number values, that something is clearly that's orange and that's purple. Those things are pretty far apart. But if the purple numbers were more close to the original orange numbers, then they'd actually be closer in the color space, which means they're closer in the vector space. The same is true for all concepts. You can do that for colors. You can do that for anything that you can create into an array of numbers. That's what the vector search is. So rather than I guess that's the impact of that for comparing to Lucene search. For Lucene search, you're really looking for occurrences of literal text characters and like maybe similar characters, variations on characters. You could have wildcards and things like that, of course, but it doesn't have the concepts. When you turn something into a vector, you're really capturing the essence of the concepts and putting that into a space where similar concepts have very close distances inside of the vector space. I've now talked too long and I can't see your faces to know if that was a reasonable answer or not. Michael, what did you think about that? Does that sound like a fair way to describe it?
Yeah, well, I'll admit I'm still learning and ramping up in this space as well too. But I actually really technology of the using the color space as well too, because I hadn't quite thought of it as a vector before, but now it makes a lot of sense. I think one of the follow-up questions I have, and probably anticipate somebody else. So in the color space, it's not too hard to think about. Okay, here's the number representation, but how do you actually create some of those vectors and the embeddings? Like what tools or what processes typically involved with actually creating those embeddings?
Yeah, so that's where we actually turn to the LLM, and so that's part of what is good about the models is that you also get vector embedding APIs with all the LLMs. So you don't do the vector calculations yourself. You take some text that you would like to actually create a vector for, and you pass that through the machinery. Basically, out pops the number that says, okay, well that's here's what the vector embedding would look like for that document or for that piece of text. So even from like in the RAG flow that we have now, like in the chatbot, the original user input, that's just a bunch of text. We could just do some regular Lucene kind of text matching on that stuff. We could try to do even classic NLP stuff, right? We could try to pull out what are the what's the topic you're actually talking about. What are the what did you actually ask a question? Is it something else? You can do a lot of kind of standard NLP stuff with it. All of that kind of work has now been transferred into LLM land, where by the benefit of all the training of these models, their sense of what things are, what language represents and means, is much more refined than you get out of basic NLP processes.
Sure. Okay. And so Joe, who asked the original question, had a follow up, and it's probably mostly just to make sure he understands. You said, but if I stay in the Lucene mindset, I think of Lucene as describing whole documents. The LLM also describes the whole document as one thing.
Yeah, I think that's right.
Yeah.
Yeah, that's right. And so it's interesting, like, and of course, like today we're combining kind of vector search with graph pattern matching as well. You can imagine each of these different techniques actually being combined, because maybe there's a combination that actually gets you the best results. Because sometimes maybe you do want an exact match of like, no, I'm looking not for the concept of this thing. I want exactly what I'm asking for. Like I know that I get frustrated with Google sometimes, when I know exactly what I'm looking for, and because I forget the thing I'm typing in actually has a broader general purpose meaning, the results I get back are not relevant to me because Google doesn't know the context that's in my head. I've just switched from doing some coding work and I'm thinking about a coding question and it answers it in like a pop cultural way. And I'm like, no. I don't. Yeah, I get why you've answered that, Google, but you're wrong. And you kind of have the same experience sometimes with LLMs, and even with the vector search, I suppose.
Yep. Fantastic. All right. Rick asked another question, and feel free to either answer now or if you want to hold off on a little bit.
Yeah,
He said,
let's go for it.
so it said, this similarity search will match answers that sound like the questions. How would one implement a hide hypothetical document embeddings approach in Cypher here?
So I guess it's all the same thing. You can decide what you want to do the embeddings around and like what you want to do, how you want to use the vector search. It's the same patterns apply. You take all the documents you've got, you create vector embeddings for them, and you add that vector embedding into the database. When you look at the details inside of the code that you'll see inside of chains.py, or if you just look at the raw database inside of Neo4j, you'll see that each of the data records that has an embedding has a field called embeddings that has basically this array of numbers. So it doesn't matter if you want to do that for the questions or for the answers or for anything else. It's the same basic approach. And then you decide how you want to combine the vector indexing with then a Cypher query, or don't do the Cypher query. If the vector embedding is just enough, then that's great. There's different approaches. In fact, what I'm doing today, of course, is the preferred approach, I think, because that gets the best answers, combining a little bit of vector and a little bit of graph. But you could do just vector, or you could do just graph if you want to. It all depends on what makes sense. And for just doing the answers, the patterns is exactly the same. So you could just change what we've done here. Instead of focusing on the questions, you can focus on answers instead. If you have some way of getting the answers, and you want to find similar answers, you can still do that lookup as well.
Got it. And that's all the questions so far. So,
okay, I'll keep going then for a little bit.
Yep,
we'll see what else pops up. Oh, and actually, we're actually close to the end. I forgot that. So what we've done so far is we've gotten a vector embedding, using Neo4j vector. We've passed the results of that for the questions, and was it Joe's question? Joe's question about the questions. Here we're focusing on the questions. Let's find similar questions that have been asked before in Stack Overflow. We'll do a pattern match to get any of the answers for those questions, return those, bundle that all up into a bunch of text that we can then pass finally back to the LLM to do its natural language magic and present it to the user in a nice way. And all that packaging up, the kind of the chain part of the LangChain happens here inside of the retrieval question answer with sources chain, where we pass in, the chain itself that we've set up before. The knowledge graph, we can actually there's a call into the value that we've got that we can say, okay, return the thing you've created as a retriever. So we know that we're going to be plugging it into this call here. So that's what the kg as retriever does. And this resulting, kg underscore QA, it's the knowledge graph Q&A chain, is what actually does everything. So this kind of all the setup we've done is to create that final function. And then that function just gets fed with input from the user, and then the kind of whole process kind of rolls along. So if you want to modify this stuff for your own, you've got examples to work with here inside of the bot itself. There's a few other examples, and I think probably every week we'll keep adding examples here and trying to refine stuff. And I'd love to hear back from anybody who's listening in today, or who finds this later on kind of online. If there's examples you'd like to see, like something you're exploring that you don't think quite works, or something that we haven't demonstrated that you think that might be useful, go ahead and ask us. We're working on new examples all the time. This is new live stuff for all of us. So we're learning some of this, kind of along with you. We know the graph stuff super well. We know the vector stuff super well. How you're trying to apply it, it's the classic, okay, now it depends. There's different approaches for different things. So, reach out to us on the Docker Slack channels, or, directly if you want to as well, that's fine also. But at the end of the day, you've got a great baseline to kind of just works out of the box. You can get it going. You can start by just tinkering with it a little bit, pulling in maybe some different data sources, and then just see where that leads you. And I think this is going to be really great for showing some really great applications that you can do with GenAI. Okay, and so this is thanks for real this time, not my fake thanks that I started out earlier as. And Michael, if there's any other questions, I could take those now.
Yeah, absolutely. Well, first off, I'll give you the first round of applause here and say, well done on the presentation. I'll admit I learned quite a few new things there as well too, and between new things with things I didn't know that I could do with the Cypher query language, but then also just how all the pieces are fitting together as well too. So thanks for filling in a lot of those gaps. I'll go ahead and just remind everybody that's watching too, if you've got more questions, feel free to drop them in the chat as well too. We'll see what additional questions come up here. But while questions are coming in, just kind of reminder of, again, if you haven't signed up for the hackathon, feel free to do so. The link is up at the top of the chat feed as well. It's being we're working with DevPost to help manage and run the hackathon as well. There's a lot of additional resources that are available there, including links to other documentation, and Neo4j has done several fantastic blog posts to help explain a lot of the things that we were just talking about as well today too. And additional resources, there's links to the Docker Community Slack workspace as well too, and there's a channel specifically for the hackathon where you can ask questions, or hey, I want to do something, but I don't know where to start, or I need ideas. There's actually been a lot of great conversations going on in there as well too. Or if you want to partner with somebody and work together on a team, again, feel free to drop into the Slack channel there as well too. So, all right, it looks like Bruno has passed along a question to us. So Bruno asks, what about using Neo4j to persist conversation knowledge graph from LangChain? Any plans for the future?
Oh, I love that. So we tried to keep our examples pretty simple right now. There's another group inside of Neo4j who's put together a pretty fantastic, I was going to call it a demo, but it's more than a demo at this point, like something called Neo Agent, or Agent Neo. I think that's the name, Agent Neo. And Agent Neo, I think this is maybe what you're asking about, but one of the awesome things about once you've actually got a database on hand, in addition to having the large language model, is okay, now you can do databasey stuff. And so what they've done with Agent Neo is not only is it a little bit of a chat interface, you can ask it questions, you get some answers, but it pays attention. It's like, okay, well, here's the questions that were asked. We're going to follow all that. We're actually going to do some ranking of all that, figure out some analysis of that as well. And you end up with this really cool feedback loop where like the more the people use the data, the more the knowledge graph knows about what kinds of things people ask. And like later people end up getting better answers because like there's other people who've kind of been through this before. So it's a little bit like the way that, and again, I'll just use Google because we all know the experience, right? Like Google gets better the more you use it, right? Like it starts to figure out, what you're doing. Okay, it doesn't always. It's not good at context switches, but generally, like the more people use it, the more it knows about like what people want, what you want, and you can do the same thing by every time people go through this kind of the RAG process along the way. Don't just provide the answer. Start storing what was the pattern that led people through here, learn from that, improve the results over time. And like you end up tuning this knowledge graph to be personalized because now you could actually say, okay, not only do we know this information, we know what information matters to people. And you could start to do some things like, okay, well, who asked this question? And I think back to being a little bit to my Google complaint. If another developer asks the thing I just asked, don't give them the pop cultural answer, give them the developer answer. You can start to like, do things like that and really personalize things. So I love that idea. I'm not sure if that's what you're asking about, quite brilliant, but that's what occurred to me about your question.
Yeah, it looks like Allison's also trying to the webinar in the chat as well too. So thanks for the question, Bruno. It looks like we don't have any other questions. Maybe we'll give it a couple more seconds to see if any others show up here as well too. But I guess maybe just one question while we're waiting for a second here too. What are you excited about next? Because I know this is constantly evolving and growing, but like what do you see on the horizon that's got you really excited?
Yeah, that's a fantastic question. And sometimes it's hard to see over the horizon because there's so much happening, right? And so it's like every day when you wake up and you kind of like, read through the newsfeed about like what's been going on, it's like, oh my God, this stuff is amazing. Oh my God, this stuff is amazing. I guess what I'm looking forward to is when I see coming next, if I think through to like next year, like we're just starting, this is the easy thing to say, right? Like we're scratching the surface of what's possible here. And I think particularly with like this kind of RAG pattern, we're like, okay, we're doing some reasonable things. We're getting better results from that. But I really do think that there's a next step past that where in some ways this is if I can be somewhat, philosophical about this, all of the fear about, artificial intelligence taking over the world, like I feel like there's this kind of companion aspect to it that is really like powerful. And like it's hinted at with the co-pilot, phrasing around things. Like when you say that, it's like, okay, yeah, this is actually a friend that you've got. I'm looking forward to that happening everywhere, where the experience that we have, and even like with Bruno's question, like, okay, when I'm using an AI, I know that the AI knows me, knows what I care about, and it's going to make me just superhuman. There really is going to be this, dare I say it, kind of like fantastic kind of symbiotic relationship. Maybe not quite Borg level yet, but we'll see how fast, that Elon works on his Neuralink. We'll get there too.
Yeah, fantastic, and I think that's kind of the sweet spot where we're all trying to get to as well. And I'm excited that. I mean, as you mentioned, it seems like every other day there's some new advancement or new capabilities, new features, and whatnot. And it's exciting to see how it's getting to the point now where it can get into really anybody's hands, and folks can start. And that's one of the things I'm excited about, kind of the GenAI Stack. Because I'll admit, beforehand, it was very much like, okay, I'm seeing a lot of this, but how do I actually get hands-on? How do I build something? How do I start testing with it? And now it's, there's still probably several more steps we can continue to evolve to make it even more accessible and whatnot. But it's starting to help democratize this a little bit and make it available to even more as well too. So
yeah, absolutely agree.
Yeah. So.
Yeah, and I love that aspect as well. Like there's this idea of like the obviously low code, no code kind of predates any of the stuff. We're quite a ways away from low code, no coding of LLM applications. But that kind of sets the bar, right? Like the expectation is like, but just the chat interface itself is so powerful. We know we want to do all this other integration to kind of lift it up and like root it in reality, root it in data that we have and personalize it for us. But that's kind of heavy lifting really at this point. But it's so clear to me because like there's so many like smart people working the problem that like one piece at a time, we're just going to like set it up, knock it down, set it up, knock it down. and it'll get to that same level. Like to some degree, the AI people have been working in the background for 30 years on this stuff, and now suddenly it's super easy and powerful. It took them a while to get there.
Yeah.
Now we've got to catch, we've got to meet them on the other side a little bit, and then together we will usher in a new age for humanity.
Fantastic. Awesome. Well, thank you for that. All right. Well, it doesn't look like we've got any more questions coming through. Any final parting thoughts or words of advice or anything for our hackathon participants?
Yeah, I think the advice is really just don't be afraid. Don't be intimidated by this stuff. It's intimidating to all of us. This is new, like within the last year for everyone. Don't let that hold you back. One of the things I love about this for developers particularly, I know there's, again, concern about like, oh, this is going to take developer jobs away. I don't believe that at all. This is going to make us all superhuman developers. Now we are part of the creative class to some degree, right? Like we can actually just, all the ideas that are in your head, now you actually have tooling that actually can take those ideas and like do fun stuff with it. So I can't wait to see what people come up with for the hackathon. I'm looking forward to seeing the results. Thank you for having me today, Michael. This has been a lot of fun.
Absolutely. And again, thanks to you as well, too. Thanks for the presentation and for the content and helping us all learn something new, too. Again, for those that are joining along, we'll put links in the description. The recording will be made available afterwards here on YouTube, and we'll also post it in dev posts as well. And good luck hacking, and see you online. Thanks all.